Hello everyone, in this video we're going to learn how to derive the formulas in Form 5 Additional Mathematics. We start off with Chapter 1, Circular Measures, where in subtopic 1.2, arc length of a circle, we learn how to derive the formula for the arc length of a circle with the center O. Okay, to start, we first label the minor arc here as S, where the radius of a circle is R and the angle subtended at the center is theta. So we learned in lower form that the arc length is proportional to the angle subtended at the center. So the arc length S over theta is equals to the circumference, which is this circumference, over the angle of one whole turn, which is 360 degrees. Yeah, 360 degrees. But if we want to represent the angles in the unit radian, then 360 will be written as 2 pi. And remember the circumference formula is 2 pi r. Hence 2 pi and 2 pi r, we can further simplify this, cancel this. You get s over theta equals to r, hence s equals to r theta, where theta is in the radian unit. And our next formula from the subtopic 1.3, area of a sector of a circle, we learn to derive the formula for the area of a sector of a circle, okay, which is a equals to 1 over 2 r squared theta. We are going to use a similar diagram, but this time we are going to use A to represent the area of the minor sector OAB. So A, the minor sector of OAB, is proportional to the angle subtended at the center here, so A over theta, and this is equals to the area of the whole circle, over the angle of one whole turn, again, which is 360. And again, since we are going to write this in the radian form, so 360 is represented by 2 pi radian. Next, the area of a circle as a formula of pi r squared. Hence, if we move the theta to the other side and we try to simplify this by cancel the pi, you have A equals to 1 over 2 r squared and the theta, where theta is in the radian form. And this is your formula. Next, we look at Chapter 6, Trigonometric Functions. 6.4 Basic Identities. We have 3 identities here where we need to derive all of them. We can derive the basic identities by either using right angle triangle on the left here, or by using the unit circle, which is on the right. I will show you both. First, we need to label the triangles here with the 3 vertices with the capital letter ABC. Then, for angle A, the opposite side here we label with the small letter a. For this angle, the opposite is C, and for this angle, for these vertices, the opposite side will be labeled as small letter b. Notice that this is the right angle triangle, hence C is the hypotenuse. Then for this angle, sine of angle A will be the opposite side, which is A, over the hypotenuse C. For the cosine of A, it will be the adjacent side here, the B, over the hypotenuse, B over C. And for tangent of A, you will have the opposite side over the adjacent side. Then we need to use the Pythagoras theorem, which states that the sum of the square of the two sides here, A squared and B squared, where you add this up, you get the square of the hypotenuse. So I'm going to write this down at the side by using Pythagoras theorem. A squared plus B squared equals to C squared. So if we want to form the first basic identities here, notice that this is 1. So how are we going to change this to 1? By dividing all the terms with C squared. So A squared over C squared plus B squared over C squared equals to C squared over C squared. Then this is actually A over C squared, this is B over C squared, and this is C squared over C squared is 1, And you can see that a over c here is actually, a over c is actually sine a. Hence we have sine a squared, or we can write this as this. And also b over c is actually cosine. Okay, b over c is cosine, hence we have here our cosine squared a, which is equals to 1. Hence we derive our first basic identity. Then for the second identities, we refer to this again. Second is 1 over cosine. So second squared will be 1 over cosine squared. And cosine here, cosine is b over c. Cosine is b over c. Hence this becomes 1 over b over c. 1 over b over c is actually 1 divided by b over c, which is 1 multiplied c over b. And hence this is actually equals to c over b squared. So if you want this part to be second squared a, you need to divide this by b squared. And so we are going to divide all the terms by b squared. So you have a squared over b squared, b squared over b squared, and c squared over b squared. Here you have a over b squared, b squared over b squared becomes 1, and here we have c over b squared, and a over b is tangent. You have tangent squared a plus 1, and as we already mentioned just now, c over b is actually 1 over cosine. Because b over c is cosine, so if we flip this c and b, the numerator and denominator, c over b, it is 1 over cosine a. Okay, so hence c over b is 1 over cosine a, which is second a. We have a squared here, so we have a squared here, and we can rearrange this such that it matches the identities given here. And so I think you know what we need to do in order to get the third identity, which is by dividing with a squared. So a squared over a squared plus b squared over a squared equals to c squared over a squared. A over a is 1, b over a, b over a, c over a, c over a. You'll notice that we don't have b over a or c over a here, but we do have a over b. So if we switch these two, you get b over a. This is actually equals to 1 over tangent. And likewise for a and c, if we switch this, c over a, this becomes 1 over sine a. So if we have 1 plus tangent a, c over a will be 1 over sine a. And 1 over tangent is actually cotangent, and 1 over sine a is cosecant squared a. Hence we get the third identities. And for the second method of using the unit circle, we call this a unit circle. We first have to try to understand the basics related to unit circle. So first of all, unit circle has a radius of 1 unit. This means that any point on the line, any point on the circumference, if you draw a line from that point to the origin, it is actually the radius of the circle, which has a unit of 1. Okay? Any line has a unit of 1. And hence, if I have a point here, I draw the radius of which is of unit 1, and I draw a vertical line here. I'll form a right angle triangle. And then the horizontal length here will be denoted by the x value, where the vertical length here, y here. And notice that the coordinate of this point is also x and y. Now for this triangle, if I let this to be the angle, then sine theta, according to the definition, will be the ratio of the opposite side to the hypotenuse of this right angle triangle. Okay, the opposite over the hypotenuse. So opposite over hypotenuse. And you will get it is y, the y value here. So sine theta equals to the y value. Likewise, if you want to find the cosine theta, it is equals to the adjacent side over the hypotenuse. So adjacent over hypotenuse, cosine theta equals to x. And hence we can find the x value by finding cosine theta, and we can find the y value by finding the sine theta. And one more thing is the length of this side, which is denoted by x, is also the cosine theta, and the height here, which is denoted by y, is sine theta. And this is how you get this diagram here, where the horizontal length is cosine theta, and this length, the vertical length of the right angle triangle, is sine theta. So once you are able to draw this diagram, we again use the Pythagoras theorem, which states that the square of this plus the square of this equals to the square of the hypotenuse, because this is a right angle triangle. So sine squared theta plus cosine squared theta equals to 1 theta by using Pythagoras theorem. And this is actually our first, which is equals to 1. Hence, we have proved our first basic identities. Then, to derive the second identities, notice that we want this value 1 here to be second squared. So, we need to divide. How do we get second squared from 1? By dividing this with cosine squared. Hence, all the terms here, we divide all the terms by cosine squared theta. Hence, you have sine squared theta, cosine squared theta plus cosine squared theta over cosine squared theta equals to 1 over cosine squared theta. Sine squared theta over cosine squared theta is actually sine theta over cosine theta squared. And this you get 1. Here you get second squared theta. And sine over cos is actually tangent. Hence you get your tangent squared theta plus 1. And you rearrange this according to the given formula. For the third formula, we want this side, this 1 to be cosecant, which is by dividing 1 with sine squared theta. And hence all the terms have to be divided by sine squared theta. So this you get 1, cancel 1. Cosine over sine is cosine theta over sine theta squared equals to cosecant squared theta. Cosine over sine is actually cotangent. Hence, you get the formula. And now we move on to 6.5, addition formulae and double angle formulae. So to derive the formula, so there are 3 sets. The first one is sine 2a, the second one is cosine 2a, and the last one is tangent 2a. And all these double angle formulae can be derived by using the addition formulae, which is also given in the formula list during the exam. And so to derive this, we need to start with the addition formula, where we only take the positive part, which is sine a plus b equals to sine a cosine b plus cosine a sine b. And to get 2a, we only have to change the b here to a. Okay, so if b equals to a, sine a plus a, then all the b's here have to change to a as well. A. So this equals to sine 2a, whereas sine a times cosine a is actually equals to cosine a times sine a. So it means that we have two of the same terms. Hence, we have the 2 sine a cosine a. Likewise, for the second formula, cosine 2a, we also take the positive part, which is the upper part of the symbol given here. Okay, if you take this, you have to take this. So we start with cosine a plus b. So to get the first one, if we let b to become a, then we will have cosine So a plus a, you get 2a, whereas cosine a times cosine a, you get cosine a squared, minus sine a times sine a, you have sine a squared, which is the first one. Then we proceed from here to get the second formula. So you notice that in the second formula, we don't have sine anymore. So means we need to substitute this with something. Your basic identities, the first basic identities, this one, sine a squared plus cosine a squared equals to 1. So we are going to use sine a squared plus cosine a squared equals to 1. So in order to substitute this with cosine, we have to write this in terms of cosine. So it becomes, so we move this here, you get this equals to 1 minus cosine a squared. Hence, we are going to substitute this with 1 minus cosine squared, a squared. You get this 1 minus, so negative, negative becomes positive. And cosine a squared plus cosine a squared, you get 2 minus 1, which is the second. So to derive this, we want to substitute cosine with sine. Hence, we want to write cosine in terms of sine. So we just move this to the other side. You get this. Cosine a squared can be replaced by 1 minus sine a squared. And this is from here. Okay? And now you have 1 minus 2 sine a squared, which is shown. And for the third one, again, we are taking tangent a plus b. We take this, and this, the upper part of the symbol. Hence, you have tangent a plus tangent b over 1 minus tangent a times tangent b. So if you replace b with a, you have tangent a plus a, tangent a, and all the b's here becomes a, tangent a, 1 minus tangent a times tangent a. Tangent a plus tangent a, you get 2 tangent a. Whereas tangent a times tangent a, you get tangent a squared, which is, of course, this is your tangent to a. And now we have an extra part where we are going to derive the half angle formula. You'll notice that this is a bit different than the earlier printed textbook because there is an errata which is made by the publisher. Hence, this is the latest one for the tangent a over 2. And so we're going to see how to derive the first half angle formula, sine a over 2, by using the cosine 2a formula, the double angle formula. And notice that the half angle formula actually is not given in the exam. If you need to use this, you have to derive it yourself. So to derive this, we use this double angle formula, which is given in the formula list. So if we want to find sine a over 2, means we are going to use this, then we need the angle in half. So if cosine 2a equals to 1 minus 2 sine a squared, if you want this to be in half, this will always also be in half. You'll get cosine a equals to 1 minus 2 sine a over 2 squared. But since we want this to be in as a subject, I will flip the left and right. I'll get 1 minus 2 sine a over 2 squared equals to cosine a. Then I move the 1, it will become this. In order to get this, I need the 2 to be positive. Hence, I just multiply the numerator and the denominator by negative 1. Then I will get, from here, I will get negative cosine a plus 1 over 2. And these two, I just rearrange it. Here, it becomes square root, becomes plus minus square root. Hence, I've derived the formula. Okay, for cosine A over 2, we need to use this part of the formula, the double angle formula. So we're going to start from here. Cosine 2A equals to 2 cosine A squared minus 1. And we are going to take half of the angles. Okay, so here divide by 2, here divide by 2. Yep. Then we're going to flip both sides here. You get this. Then I move the square to the other side. It becomes plus minus square root. And I rearrange this such that it matches the formula given here. So I have 1 plus cosine A over 2. Third one, tangent A over 2, is slightly different because you are now going to use sine A over 2 and cosine A over 2 instead to get tangent. So the basic concept here is tangent theta is always equals to sine theta over cosine theta. So to get tangent A over 2, we can write this as sine A over 2 over cosine A over 2. Sine A over 2, we already derived this just now, so you get 1 plus minus square root of 1 minus cosine A over 2. And for cosine A over 2, we have this 1 plus cosine A over 2. We can combine this, so you get this 1 minus cosine A over 2 over 1 plus cosine A over 2. 2 and 2 here cancelled. You will get this 1 minus cosine A over 1 plus cosine A for tangent A over 2. And that's it for chapter 6.